at section 4.1, 196 in your textbook or your phone. We're looking at interpreting the solution of a linear equation. So I did mention this as I was writing it. One of the nice things I do like about, and a few things I like about the Nelson book, is the fact that they mention the goal of what we're learning today, or what we're trying to learn today. And that is simply to relate equations to table of values and graphs. Okay, so we've talked about it a bit in the past in chapter 3. We talked about 3 different methods to find solutions to linear equations, them being the table of values, the graphing, and then using algebra or equation method itself to find answers. Okay, and I said that I prefer the equation method. Typically it tends to be the fastest and the most accurate. Okay, we're going to see that same kind of repeating theme in this lesson. So the first question involves a website service company, or a hosting service company for websites called UHost. And it tells us that they charge $19 monthly, and they charge $1.15 per megabyte of storage. So this is really expensive. So it gives you an idea of where technology has already come, because to give you guys an idea, what I pay for our website, shamnation.com, which also includes all your email addresses, as you know from our tech class, I pay $12 per year to host that site, and then I pay nothing for storage at all. Okay, so this probably, when written, was relatively accurate. I'm sure the author of this book didn't pull these numbers out of nowhere, but it just gives you an idea. Again, even going back to that idea of the film, with technology prices coming down already, with when this book was written, which I think was 2007 until now, you can see the prices come down, tenfold of what it would cost. Okay, each of you, by the way, with your Google accounts, get 20 gigs of storage each. Okay, so it's a lot, right? Here they're trying to charge $150 per megabyte. You guys get 20 gigabytes. All right, so we're talking about a big difference, and that tells you how quickly and how massive the internet is expanding. Okay, quite aggressively. And the fact that Google's giving out, from what I understand, I have unlimited accounts at this point, $12 a year. Granted, it's an education license. If it was a business license, I think each one of you guys would cost about $25 per email per year. So it would get expensive very quick. Yeah.
You pay $12 for each email?
I paid $12 for shamnation.com. All right, so it says, how many megabytes of storage can Marianne purchase for $60 per month? So right away, just given on that question, I hope most of you start thinking equation. Okay, because I know I start thinking equation, and I want to try and build an equation. This particular section, it's not in your daily plan, but I suspect part of the reason why the teacher, prior to myself, didn't include it was the fact that they're talking about estimating a lot and using table of values and graphs. I think it's important that we go through what they do, but at the end of the day, I want to show you the equation method as well, because I think that should be the one that you guys should choose if given a choice. Okay, so using our table of values, so I just labeled it here TOV, I have megabytes on the left-hand side and total cost. We know that the independent variable, first of all, is which one? Jacob? Megabytes or total cost? Independent. Sorry?
Megabyte.
Right, megabytes would be independent, so listed on the left-hand side. And it's how much we choose, right? We can choose how much megabytes because we make a decision on how much data we want to download. All right, the cost, obviously, is something that's measured or calculated. All right, so that's why it would be the dependent variable. And then each situation, depending on how many megabytes I use, I calculate how much that will cost me. So if it's $19 is my flat rate, I'm always going to have $19 a month. So that's total cost per month there. Let's put that in per month. Okay, so we have $19 always times the cost of the megabyte times however many there are. In the first scenario, there's none, so I times 1.15 times 0. That leaves me with just 19. In the second scenario, there's 10, so I'm going to sub in 10 for the number of megabytes, times it by 1.15, which is 11.5. Add that to 19, I get 30.5. Okay, I think that's pretty self-explanatory. I continue down doing that with the different values of megabytes. Okay, and then the question says, how much can we purchase for $60 per month? So using a table of values, we can see once we get to 40 megabytes, we're already above $60. We're at 65. So we can see that for $60, we're going to be somewhere in between 30 and 40 megabytes. You guys see that? So we can say, you know, an estimated value of 35 megabytes for $60. Any questions about that? How I decided it was 35? Pretty much right in the middle between 53 and 65. Okay. It's actually going to be a bit lower. It would be right in the middle. 35 would be a bit lower. All right, next. Next situation is using a graph. So now all we would do is take these points and graph it. Okay? Graph might give you a little bit more accurate answer, because what you can do then with a graph is you're going to locate the cost of $60, which would be on the y-axis, remember, because that's the measured or dependent variable. We put it on the y-axis. Some of you guys had this opposite on the test. Remember, the dependent always goes on y, independent on the x. So then we find $60, we trace it across, we see where that line hits. And remember, this line is created based off these points, right? These are our data points, 0 and 19, 10, 30.5. And then we trace that value down. And again, we can see that it's somewhere between 30 and 40. All right, so depending on how accurately you drew your graph, or how much graph paper you have, arguably this method you could say is a little more accurate. Okay, you know, it's a toss-up depending on what variables or what values you chose here as well, right? You could have done this one by one, right, and got pretty accurate doing it that way. Finally, the equation, which is of course my preferred one, is your total cost is equal to your monthly charge plus your cost per megabyte times the number of megabytes you use. Right? We basically had to already develop this model to do even the table of values, right? If you can notice that equation, you know, that's the main part of this equation here. The only difference is that we're now subbing in 60, because that's the value we've been asked to calculate for. Once we do that, we need to rearrange this equation to solve for x. A few of you guys had trouble doing this, especially on the application section of the test in Chapter 3. I would strongly recommend to come see me tomorrow after school and just clarify it, because this algebra, this stuff, moving things over, you know, negative signs changing, dividing things and canceling out, I'm telling you, it goes with you right through high school. Literally every single day in grade 10 you'll need it. Okay, so it's not something that's going to go away. It's like something as basic as, you know, addition was for elementary school. This type of playing and fiddling with the numbers and moving them around and dividing them to isolate for a variable, okay, it's called algebra, this whole process. It's not going anywhere. So if you got any part of that wrong on the test, make sure you come see me. It won't be necessarily for a long time, but we should clarify it now. Okay? So all I do here is I want to isolate for x, so I'm moving the 19 over, so it becomes negative. So 60 minus 19 is 41. And then I still have this 1.15 that's stuck to my x, so I need to divide both sides by 1.15. Okay, I don't show it on this side because I know they're going to cancel, so I just show it on the left-hand side and leave x on the right. Okay? I'm starting to drop some steps here, as you'll notice as we go through. Just because this should become more and more familiar to you guys. It's going to become easier and easier. So that gives us x, we know is 35.65. So looking at this problem now, we got an estimate of 35. We got another estimate here of 35. And then our equation told us it was 35.65. All right? So again, I wouldn't say either that the equation took much longer. If anything, I'd say it's probably quicker. All right? It's faster, it was easier, and it was more accurate. So if you're given a choice, you're going to try and use the equation method. Michael?
Can you change the 60 to the right side?
Sure, but then you'd have to move everything to the left side. So, okay, let's do that. So if we did do that, let's just move over the 60 to the right side. What we'd be left with on the left side would be 0, right? So we have 0 equals 19 plus 1.15 x minus 60. Okay? So you can do that, but now it's getting a little messy, right? So we have 19 minus 60. So now we have 0 equals negative 41 plus 1.15 x. All right? Now you can either move this back over and it becomes positive, kind of where we were, or you can move the x if you want the variable on the left-hand side, which is kind of more standard. We'll move that over, so we get negative 1.15 x equals negative 41. Okay? And now you would divide this by negative 1.15, so these cancel, and divide this by negative 1.15. And you'll get the same answer, right? Because the negative signs will cancel, and you're going to get 41 divided by 1.15. Okay? So yeah, you could have. This way is a lot neater and simpler. Okay? Any other questions with that? All right, moving on. Example 2. All right, it says, using a graphical representation of a relation to solve an equation. So we're given this equation. Right away, it says solve the equation. My instinct is to use algebra immediately and solve for x. Okay, it's asking us to graph it to solve. So I just want to show you how to do this process, right? So when we have this equation, it says to graph it. The first thing I want to realize is that it's very similar to the equation that we should all recognize, which is y equals mx plus b. That's the equation for a straight line. We should recognize that this equation is a straight line, okay, because the degree is only 1, and it's only got one variable. So that should kind of ring a bell there. So if that's the case, then what we want to do is graph this line. Sorry, graph this line in this format. So y in this case is going to be 20. So we graph this, y equals 3.5x plus 2.5. Okay, that's exactly this. We graph that. It's a line that looks like this. And then to find the solution, we want to know, well, what's the x value when y is 20? So I go up to 20 for y. I go directly horizontal until I hit the line. I go down. That's my x value. That's the solution. Okay? So by algebra, that's by graphing. We're going to find the x value that way. By algebra, again, we get into this this method of moving numbers over the equal sign, changing the sign, dividing, and then giving it a final answer. What's 17.5 divided by 3.5? Somebody? Yep.
5.
Just 5? Thank you. Okay. Any questions there? All right, good. I hope that's getting pretty easy now. Example 3. It says determine the x-intercept of a linear relation. I don't see anything new here yet from chapter 3. You guys? No, so far we should be pretty familiar with this stuff. We know when we're looking for an x-intercept, we want to set the y value to 0, right? Because on a graph, here's our y-axis, here's our x-axis. Well, whenever it crosses the x value, the y value has to be 0. So that's how we know that. Okay, I've said this a few times now, but surprisingly on the test, some guys didn't get that. Even though we've done all the homework questions, it surprises me. So x-intercept when y is 0, I sub in 0 for y. And now I have equal to 3x plus 2. Need to move the 2 over. Becomes negative 2 is equal to 3x. X is equal to negative 2 over 3. Yeah?
Aren't you supposed to move the 3x over? Because we isolate the variable?
Yeah, you could have done it either way. So if you wanted to move the 3x over, it would have been negative 3x is equal to 2. Is that what you're thinking?
Yeah.
Yes, it's the same thing, you'll see. So now I got to divide this by negative 3 and divide this by negative 3. So I end up with x is equal to negative 2 over 3. You see how it's the same? I just left the x on the right-hand side. Sometimes I'll do that. But there's not a bad habit of always moving everything to the left. Yeah, Kevin?
Would it be incorrect if you actually did negative 2 divided by 3?
Like this?
Yeah, no, if you put x equals negative 0.66.
Yeah, my issue with going to decimals is it's not exactly accurate, right? It's not precise. If you can leave it in fraction form, then leave it in fraction, because fraction is exactly. A lot of you guys get into trouble when you round too. So like a lot of people said for 1/3, they wanted to say 1/3 is equal to 1.3. It's not. And it's not equal to 1.33 either.
And it has like a thing on the top.
Yeah, if you put the thing on the top, then you're right. You wouldn't have to put 2 3s just because it's 1 3, you can repeat the 3. Alright, so that's accurate, but why write that when you just can leave it like that? It's so much cleaner and
So
nicer.
it would be incorrect if you put in decimals?
It would be incorrect if you rounded improperly. This would be correct still. And one thing that I did note that happened a lot on the test, you can't have this as a final answer. You can't have that. That's completely improper. You can't have decimal places in fractions. Okay? It's fine if you get that far and then you divide them and you give me a final answer. I was okay with that. But this is improper. This you don't have decimals within fractions for the most part. Okay? All right. Next question, example 4. So there's a cell phone company plan. So this is pretty relevant to most of us. Most of us have cell phone companies, cell phone plans. This particular one's charging $9.95 per month and 50 minutes free. Notice there's no data. And let Y be the total cost for the month. So these could have been different, right? You could have said the total cost is T, and you could have said the number of minutes could have been M or N, right? And then your formula would have changed accordingly. But it's just important to define that first before you make your equation. So now we know our total cost is equal to the $9.95 fixed cost we pay a month plus 9 cents a minute, and this is the tricky part, times not just X, not just the number of minutes, but remember we get 50 minutes free, so we have to minus 50 minutes, so that if we have, let's say we spoke for 50 minutes on the phone, it would be 50 minus 50 is 0, we wouldn't get charged for any minutes. Okay, do you guys see how that works? Any question on that one? Alright, so we have 9 cents a minute times number of minutes minus 50. Yeah, Dan.
Wouldn't you do 50 minus X?
No. Why?
Because 50 minutes is how much you have, and then X is how much you talk.
No, because 50, if you did 50 minus X, 50 is the number of free minutes. You would be charging yourself for those 50 free minutes if you did that. Yeah?
Sometimes in a plan you don't use all 50 minutes and it's still at the flat rate. So that equation won't work in that scenario.
Yeah, that's a very good point. So in this scenario, this is the one issue with this equation that Andrea is bringing up. If you have less than 50 minutes, you're going to get a negative value here. And you're going to say, well, wait a minute, I don't even want to pay you $9.95 because this is going to give me a negative value. So in that scenario, yeah, you're right, the equation does not work. Okay? And that there is some limitations, right? When we're graphing, if we do go into the negative area in certain regions, it doesn't make sense for that particular problem. All right? But yeah, that's a good point. So at $40 a month, we're going to sub in for our total cost is going to be 40. So we set y equal to 40, and then we go ahead and solve for x. Okay? The only small little trick here, I guess, was the fact that you need to use the distributive property here, right? When we're multiplying a set of brackets, you need to multiply that 0.09 times the variable, which gives us 0.09x, and then times it by the number, which gives us negative 450. Any questions there? And now once we have this, it's just a matter of rearranging to isolate for x. I want everything away from the x, so I move this 450 away. I leave the x on, again, I left it on the right-hand side. I tend to move numbers away from the variable and leave the variable where it is, whether it's on the right side or the left side. If you feel more comfortable moving it to the left side first, that's also fine. You get the same answer, as long as you're comfortable working with the negative signs. So the 450 moves over, it becomes positive, is equal to 0.09x. And now the last step is I have to get rid of this 0.09 because it's still attached to my x. So in order to do so, I divide both sides by 0.09. I didn't show it here because it cancels, right? Divided by 0.09, this canceled. Okay, and we're left with x equals that, which ends up being 384. Okay, so that's how many minutes you can talk on the phone for $40. All right? Any questions so far at all? No? So just finally, in summary, we can use a table or graph to estimate the solution to an equation. The exact solution can be found using algebra. So this type of thing here, this moving around, dividing, I think most of you are comfortable with, but I'm going to tell you right now, I know there's about 3 or 4 of you guys in this classroom right now that's not that comfortable based on the last test. You need to come see me tomorrow and get this figured out. It's not going anywhere. Okay. Thank you.